Hey there everybody. I was going to make a video next about sorting out my messy wiring and explaining how that is connected up, but I found something else that I would like to do first. So the nutrient level in my bucket, if you can see it, is rising towards the brim. And what that indicates is that when I go through my cycle, so just to review, when I'm doing a feed cycle, the pump turns on and loads nutrients up through this pipe and down and fills this section of pipe. And because my nutrient level is climbing, that indicates that I still have nutrients in this section of pipe down here when I'm doing my feed cycle. So what I need to do is add more cycles. Right now I think I'm at 200 cycles between feedings, and I'm going to increase that to perhaps 250 so that the nutrients get closer to here before we get the feed cycle. And then if I was exactly right, if here's where the nutrients go to the nozzles, if my water was right to there, then my level would stay exactly constant, because we've displaced the nutrients that were in there and have now gone to the nozzles with water, and that should be equal, but it's not equal. My level is rising, so I need to adjust the number of cycles between feedings. And the other thing I thought I'd mention is a couple of shortcomings in my layout here. I'll probably fix them or do it differently next time, but I don't think it's good to have this area on the other side of the nozzle. I wasn't sure how many nozzles I was going to put on a row, so that's why it ended up with a T here. If I was doing it again, I would put a 90 there, so there isn't this passive area where bad things can happen, where nutrients sit over a period of time. And the same thing is happening here. I've got my pressure sensor on an extension of pipe, and I don't like having this section of pipe here that's out of the circulation loop. I would prefer to have the pressure indicator on a T in this section of pipe so that the fluid is going past it and I don't have any dead zones. So anyway, I just thought I'd mention that. But what we're going to do now is update the Raspberry Pi. Here's a closer view of it, and I'll just pause for a second and then we'll do that. For anybody who hasn't seen one before, this is a Raspberry Pi. This happens to be a Raspberry Pi 3, and it's a very small computer, different from a desktop computer in that the black rectangle that you see on the side, that ScanDisk micro SD card, is where the operating system is installed, and it just slides into a slot on the Raspberry Pi just right there, and that's where your operating system goes. And then it's got some ports on the side. There's a HDMI, and to the left of it is a micro HDMI. The power goes in on that black round connector, and then on the end there is a Ethernet connection, and on this one 4 USB connections. So that's what's on the Raspberry Pi, and what they are really good for is for controlling things. A desktop or laptop computer, you can't plug stuff into it and control it, whereas with these little guys you can do all kinds of things. So what I have over here, this is a 8 relay card or hat, and they call it that because it physically goes and mounts on top. And so that row of pins that you see right there connects with this female row of pins, such that when you put them together and you can stack it up on top, and if I turn it around here, you can see it a little bit better. Those pins, they go in here, and then it just transfers the pins up through to here again, and we could add another one of these on top and another one and on another one. On this particular one, this is an 8 relay card from Sequent Microsystems in California. We could stack eight relay cards on top of each other, and those cards are worth, I don't know, $40 or something each, and you can operate 8 relays, so it's maybe $5 each. Very inexpensive way to build a control system. On our system, we have one more card in between, just so picture this one, and then there's another one stacked on top, and then an 8 relay card on top, and that's this guy right here in the middle. And the difference with it is that it has these pins also coming out the side, and we can add a female connector, this guy here, onto the side, and it brings it out to all of these pins here. And with those pins we can do other things. We can have temperature sensors connected, humidity sensors. We can send out varying signals, like 0 to 10 volts and stuff, so we can control speed up and slow down motors, or dimmer switches, or anything. It's just a very versatile stack that we have here. And so this one, I've removed it from downstairs and disconnected all the wires that were connected to it, and those just go with these connector guys here. So all my wires downstairs are screwed into these connectors, and then these plugs just connect in. You just push them in like this. So to bring it upstairs, I just needed to pull these plugs out and disconnect the power and bring it up here and plug it back in again. Then I connected the Ethernet connection to it. The reason that I'm doing it this way is that in my house it's a long ways down to my table, and it's easier just to unplug those plugs, bring it up here, and connect the Ethernet, where it is then recognized on my house router system just like a TV or a phone or anything would be. And so then I can connect to it through a desktop computer, and what we see right here is Node-RED, which is the software that is running our sequencing for the switch timing and valves and things like that. So in Node-RED here, what we're seeing at this top part here is our feeding cycle, and then down here is our misting cycles. Right now we're on a 10-second delay there. The 10-second delay is over, and what I have right now is I have the misters on for 750 microseconds, and then a 2-second delay between them as we come down here. I actually have 11 of them in the software, and I have 11 switches on the board, but I only have 7 misters connected. So when it gets down to the bottom here, it's going to adds one more cycle to the counter, and then it follows this line back up and starts the process again. And then after it has gone through this process, you can see the blue dot marching its way down there again. After it's gone through for the number of cycles in the counter, then it will go and follow this line here and open valve 3 and delay for 5 seconds here, and go back up and go through the feeding cycle, and then start again on the misting. So what I want to do right now is change my counter. So I'm just going to double click on my counter. It's going to open this drop down box over here where I can edit it, and right now we have 200 cycles, and I'm going to change that. I think that's a little bit too low, so I'm going to change it to 240. So now I have edited that, and I'm going to be done. And then up over in the corner here, I'm going to deploy that, and it's going to tell me that it was successfully deployed. And now if I go back to my counter and double click, we can see that yes, I have 240 cycles between feeding cycles. So that's how I've made the change onto the Raspberry Pi system. So now I just have to disconnect it, take it downstairs, plug it back in again, and see if 240 cycles is better than 200. The reason that I could do this wirelessly as well, but it's a choice to make it more reliable. So for example, if I lost internet connection, I could have this Node-RED in the cloud and be sending the signals to the Raspberry Pi. And the advantage of that is that I could make changes on the Raspberry Pi over Node-RED wirelessly from anywhere. But if the internet ever went down, then the system will stop. So by having the Node-RED software physically installed right on the Raspberry Pi, it's more reliable. Even if the internet goes down, the Raspberry Pi will keep running. And one more thing, if you don't know about how switches work, so in here there's literally just a little switch, and what's happening is that just with a light switch, the wire comes in, and instead of turning the toggle up and down, this is just automatically opening and closing it and just turning it on and turning it off. And that's what's happening to the misters. They're being turned on and turned off. It's really quite simple, and I will cover that in a video about the wiring. Thanks, and that's all for now.